Okay, so we are now on proportionality, so similar polygons. So I would just like to discuss to you some examples for 7-3, but before we go to that, let me just explain to you what a similar polygon is, or how can they be similar. It says two polygons are similar if and only if their corresponding angles are congruent and the measure of their corresponding sides are proportional, with this symbol for similar. So when we say, remember, we always discuss two things here: properties for the angles and properties for the sides. So it says for the angles, they should be congruent. So if these two polygons are similar, when you look at the angles here, each angle on the bigger polygon has a corresponding angle of the same measurement in the smaller polygon. So you have the A and the A prime, the B and the B prime, the C and the C prime, the D and the D prime. So that means all four angles here is paired with or corresponds to an angle on the smaller polygon. So with respect to angles, we're good, that all angles are congruent. But this time, for the sides, they don't necessarily be congruent. But if they are congruent, then polygons that are congruent are also similar. If all sides are the same from the first and the second, they are congruent polygons. At the same time, they are similar. But when we say similar, it's more likely on two polygons that have a different size. So one is smaller, the other one is bigger. Okay, but same polygons, congruent polygons, exactly the same, are also considered to be similar. But when we talk about similar, most of the time we're dealing with different sized polygon. So we have to check the sides. So the side should be proportional. When we say proportional, we get the ratio of each side, and all the ratio must be equal. We can only find out if they are equal because these are fractions. Ratios are made up of fractions. We can only say that they are proportional if we simplify each fractions. Okay, if we simplify each fractions, then that's the time we can find out if they are similar or not. If all ends up to be 2 over 3 or 3 over 2, we have 4 2/3, 2/3, 2/3, 2/3, or 3 over 2, 3 over 2, 3 over 2, 3 over 2, or all of the fractions or all the ratios is equal to 4 over 5, 5 over 4, as long as they are the same. And take note, see that the numerators here, the AB, the BC, the CD, and the DA, they all came from the first polygon, and the denominators came from the second polygon. So it's a matter also of consistency. There's no specific rule. You can do numerator is from the left polygon and then denominator is from the right. If you choose that, you have to do that process in all ratios that you will make. If you do this from this over this, it's okay. So that means A prime D prime is similar A prime D prime over AD. Say C prime D prime over CD. Clear? Okay, so like here, we have the similarity statement, we have the congruent angles, and the corresponding sides. So it's just like naming congruent triangles before, where when we follow an order, it also gives us the proper pairing of the sides. So first letter here corresponds to its congruent angle on the second polygon. So that means A and E are equal, B and F are equal, C and G are equal, and D and H are equal. So that means AB over EF, BC over FG, CD over GH, and AD over EH. They are proportional. Okay, so just like this one, similar polygons in the example. Okay, so this one, so we have these two polygons. Determine whether the pair of triangles is similar. It's not yet given if they are similar, so we're going to determine first check the angles. We have 30 degrees, another 30 degrees. We have a 90, we have a 90. No measurement, no measurement, of course. Going back to 180, we can say that angle B is also 60 degrees and angle E is also 60 degrees. So that gives 180, 180. So all angles have a pair of corresponding angles on the other triangle from here to here. So angle A equals to angle D, angle C equals to angle F, angle B is equal to angle E. So now determine whether corresponding sides are proportional. Okay, so we pair up the sides now. So AB over DE, 12 over 9. BC over EF, 6 over 4.5. AC over DF, 6 square root of 3 over 4.5 square root of 3. So if you don't simplify them, you would right away say, oh, they are not the same, so they are not proportional. And that's why we need to simplify. Either you get the decimal value or you retain it as a fraction, right? You still simplify it as a fraction. So if you divide, the easiest way is to divide 1.333, 1.333, 1.333, so all 1.3. That means they are proportional. If you're going to simplify the fraction to make it a simplified fraction, 12 over 9, divide by 3, divide by 3, that gives us 4 over 3. 6 over 4.5, divide by 1.5, divide by 1.5, you have 4 over 3. 6 square root of 3 and 4.5 square root of 3, cross out the square root of 3. You have 6 over 4.5, like this one, you can divide it by 1.5, divide this by 1.5, 4 over 3. So 4 over 3, 4 over 3, 4 over 3. And since corresponding side, the ratios of the measures of the corresponding sides are equal, then the two triangles are similar. So if you have 5 sides, if you're dealing with pentagon, meaning you have to get 5 different ratios, 5 different fractions, and check if these 5 fractions are the same. Okay, so now how do you pair sides? When you pair sides, you pair them using the angle that is given between 30 and between 60, between 30 and 60, between 90 and 60, or between 30 and 90. Or if there's no given angle measurement, the easiest way is to pair them up according to their you arrange them from biggest to smallest, so that becomes like this one here, like this. So if, for example, you're not given with angle, you can pair 12 to 9, since 12 is the biggest and 9 is the biggest here. 6 to 4.5, since these two are the smallest, and then we have 6 square root of 3 and 4.5 square root of 3. It's what we call the common sense pairing of sides. You don't pair 12 and 4.5. You don't say 12 over 4.5. It's not proper to pair them up. Okay, so now let's go to 7-3, similar triangles. Why we have a separate lesson for similar triangles, or in fact triangles is already covered in the previous lesson, which is similar polygons. It is because we have these different we have postulate and theorem about similar triangles. So we have the AAA. Oops, let me just show this first. Okay, we have the AA similarity, and the other two, we have the SSS similarity there, and the SAS similarity. So when we had this before, when we have the congruent triangles, we deal with this as like they are the shortcut to finding out whether triangles are similar. We don't really need to look on the 3 angles and the 3 pairs of sides. We just need to look on the pairs of angles or sides that is given in each theorem or postulate. So let's start with AA similarity. What does it say? If you see 2 angles on the first and 2 angles on the second that are congruent, then automatically, without knowing the sides, without identifying if sides are proportional, these two triangles are already considered to be similar. See, we don't know what's PQ, we don't know what's TS, so we can say PQ over TS is what? But because of AA similarity from postulate 7.1, it tells us that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, so that's how you find out. First shortcut, you only need to know two pairs, two quantities here from the first and the second, so that means 4 measurements, so two pairs of angles. Next, we have the side similarity. This is used if there's no given angle. So remember that the similar polygon definition tells us that angles should be congruent and sides should be proportional. So with SSS similarity, it tells us that if you're not given with the angles, but all the sides are given, check if corresponding sides are proportional. So this is where the one that I told you a while ago comes in. That means you pair up the sides properly. So you pair the longest here to the longest here, the next to that one going down, and then the shortest over the shortest. So we are using letters here, so it's gonna be PQ over ST, QR over TU, we have RP over US, PQ over ST, QR over TU. It should be TU and then US. So that gives us A over AX and B over BX and C over CX. Cross out the X, cross out the